Welcome to the Verified Unknown. Here, curiosity is our compass, and every question is an invitation to explore. Imagine a studio bathed in shadows and soft light, question marks swirling in the air, a globe spinning slowly at the center. This is not a place for easy answers, but for deeper understanding. We don't tell you what to think. We give you the stories, the evidence, the mysteries behind the world's most compelling questions. Tonight, we begin a journey into one of the oldest debates in human history. Are you ready to see the world differently? Look up. What do you see? The sun, the moon, the stars. They trace their paths across the sky. Now look down. The ground feels solid, stable, and flat. It stretches to a horizon that looks like a straight line. For most of human history, this was our universe. A flat floor with a celestial ceiling, an intuitive idea born from everyday experience. Simple observations led to reasonable conclusions. The world was a flat, stationary plane. From ground level, the story makes sense. What is the shape of our world? One of our oldest questions. It is born of pure curiosity. We seek order in the cosmos, and the shape of our planet anchors that puzzle. Let us voyage through time to explore two very different pictures of our world. Long before telescopes and spaceships, civilizations painted their cosmos. In Egypt, Earth was flat, the sky a goddess arched above. For the Norse, Midgard was a flat disk encircled by a vast sea. These were grand myths, explanations giving meaning to life, born of cycles of day, night, and the seasons. Many cultures imagined a flat disk beneath a firmament. These models were practical, useful for calendars, seasons, and navigation. Careful observations filtered through the lens of culture and technology. They felt no motion. The simplest story was a moving sun over a still Earth. Flat Earth cosmology was entwined with religion, philosophy, and identity. Yet some thinkers noticed clues that did not fit. Pythagoras proposed a spherical Earth, perhaps for its mathematical elegance. Aristotle observed lunar eclipses. Earth's shadow was always round, like only a sphere can cast. Travelers saw new stars to the south, and ships vanished hull first over the horizon. Eratosthenes compared shadows between Syene and Alexandria, and with simple geometry, estimated Earth's circumference. Humanity had measured its world. We begin not with ridicule, but with respect for how our ancestors reasoned from what they could see. Now, fast forward to today. A small but vocal community has revived the idea of a flat Earth, most common modern model, a flat circular disk with the North Pole at the center. Continents arrayed around the center, Antarctica as a ring-like boundary holding in the oceans. Sun and moon are nearby spotlights circling above, producing day, night, and seasons with wider and tighter spirals. Above, a firmament, a dome with fixed lights for stars, turns overhead. Gravity is rejected. The disk is said to accelerate upward at 9.8 meters per second squared. It is presented as a closed system, with space travel, moon landings, and satellite imagery alleged to be an elaborate hoax. Perpetrators purportedly include space agencies and world governments to hide our true place in creation. A primary argument is personal observation. The world looks flat. Trust your eyes over experts. They argue a 25,000-mile globe should show detectable curve over distance, yet horizons seem level. They cite lasers over water appearing level across miles. Water finds its level. They claim oceans cannot adhere to a spinning sphere. If Earth spins over 1,000 miles per hour, why don't we feel it, see constant winds, or observe land rushing beneath a hovering craft? They distrust institutions, alleging CGI, fisheye distortion, and photo manipulation. Thus, every spherical image becomes evidence of a cover-up. Understanding this perspective is crucial before we weigh the scientific case. If you're enjoying this deep dive, don't forget to like, subscribe, and follow for more explorations into the world's most compelling mysteries. Science, however, offers a mountain of evidence gathered over millennia. Independent lines of observation converge on one shape. Let's examine them, carefully, respectfully, and with open eyes. We have launched satellites, probes, and people who looked back and filmed our planet. From every nation and angle, the images show the same thing: a blue sphere in space. Gravity pulls mass toward the center, shaping large bodies into spheres. The sun, the moon, the planets, and Earth. Down points to Earth's center everywhere, which is why people in Australia do not fall off. Global transport and communication rely on a spherical Earth. Pilots navigate great circle routes, shortest paths on a sphere. GPS requires orbiting satellites and trilateration, geometry that fails on a flat plane. The Coriolis effect and time zones are direct consequences of a rotating sphere. Watch a ship. Hull disappears first, then deck, then mast, sailing over curvature. At sunset, stand as the sun vanishes. Gaining a few feet of altitude lets you see it again for seconds. You have peeked over the curve. During a lunar eclipse, Earth's shadow across the moon is always curved. Only a sphere does that from any angle. Your own telescope shows worlds as spheres. To make Earth the lone exception demands an extraordinary leap. Independent lines, astronomy, navigation, physics converge on a single testable truth. The Earth is a sphere. But if evidence is strong, why does the debate persist? The answer spans psychology and sociology. For many, Flat Earth expresses distrust in institutions and thrives in online echo chambers. Confirmation bias leads us to seek supportive evidence and dismiss the rest. A centered, enclosed world can feel more meaningful than a vast, indifferent universe. Science is a method. Question, observe, test, and be willing to be wrong. From ancient Greece onward, we refined that method. Tools extend our senses, telescopes, satellites, mathematics, revealing what intuition alone cannot. We must evaluate sources, recognize fallacies, and check our own biases. The cosmos does not require belief. The invitation of science is to look at the evidence and have the courage to embrace the universe as it really is. So where does that leave us? On one side, there's a call to trust your own eyes and question powerful institutions. On the other, centuries of scientific consensus and observable phenomena from independent sources across the globe. The question we started with remains: is the flat Earth theory a carefully verified piece of the unknown or a compelling fiction? As the sun sets on this journey, imagine a lone figure gazing out at the horizon, where the sky meets the Earth and certainty blurs into wonder. We've presented the facts. Now you decide the truth. Tin hat or straight fact? What side of the horizon do you stand on? Sound off in the comments and keep questioning the world around you.